Assalamu alaikum viewers, welcome to another live stream related to derivative, related to mathematics, related to education. This live stream is going to be great. Uh, we are going to discuss some uh, great math concepts, derivative concepts, and we are gonna learn those concepts well. We are gonna discuss them in a great way, in a whole new way. Let us see that will we be able to discuss them the way we like, the way it is required. So I welcome you all in this live stream. Please keep supporting us. This channel actually needs your great support more than anything else, because without your support we cannot keep doing this work. This is a humble presentation, but when you support us, this becomes a great presentation. So let us do it. Another question related to derivative. So here is another question. Let us do that. It is derivative of natural log of cos hyperbolic 2x. So what it is? D by dx of natural log of cos hyperbolic 2x. So what is it equal to? We can have some options. Whereas I think you are not able to you're not able to watch this clearly. Are you able to watch it clearly? Please mention in the comment. Write down in the comment if you can watch it clearly. Okay, so this is the new question where we are going to differentiate this natural log function or hyperbolic function, and the options given are A, B, C, D. Four options, out of which what is correct? So among options, uh, 1 by 1 by cos hyperbolic 2x. 1 by cos hyperbolic 2x. Can it be answer? I don't think so. So 1 by 2. Actually, to know what is the correct answer, we need to apply some rules, uh, which are derivative rules, and then we'll be able to find the correct option. In fact, audience, viewers, it is not possible to guess the answer, but it is possible to calculate or find the answer by applying rules. So let us apply rules, and let us figure out what is the correct option. You know that what rule applies here? D by dx of natural log of cos hyperbolic 2x. First of all, before d by dx, what is before d by dx is natural log. So the rule is that whatever natural log applies on appears in this form, 1 by, so natural log applies on cos hyperbolic 2x, so it becomes 1 by cos hyperbolic 2x. And then we are going to differentiate that on which log applies. So log applies on cos hyperbolic 2x. Then we will have to differentiate that. So 1 by cos can be written as it is, 1 by cos hyperbolic 2x Derivative of cos hyperbolic 2x is sine hyperbolic. Derivative of cos hyperbolic is sine hyperbolic with the same 2x appearing here. And now the derivative of 2x will also be calculated. After that, we can see that 1 by cos hyperbolic 2x appears unchanged as it is. Then sine hyperbolic 2x, derivative of 2x is 2, right? So 2 can be brought out, dx by dx will be 1, means derivative of 2x will be 2. So what do you think the answer can be? We can see them making a fraction. Sine hyperbolic by cos hyperbolic make tan hyperbolic 2x. Along with this 2 appearing as coefficient. So do we have such answer, such option? Obviously we have this option appearing and delta position. So delta is the correct option, D is correct option, where 2 tan hyperbolic 2x. By applying rules, we found it, and now we are happy than anyone in the world that we have solved this question correct. So students, this is the pleasure which a mathematics student or the one who is solving mathematics attains. It's kind of a pleasure no one can even think of and the globe. So you can observe the solution, observe the rules used here, and you can enjoy the pleasure. Actually, I am enjoying that. Now, what do we have next? There is a question which I used to solve yesterday in another live stream I had yesterday, and I tried to solve that yesterday, but that question has a different way also. So let us attempt that. Let me present that before you. So let us look at it. It happens in the live stream. Sometimes the audience increases, sometimes it reduces. So I'd like to request you all to stay connected, stay here in order to observe which rules of mathematics are being discussed, and which rules are actually you are monitoring. Should not be presented badly here, should not be presented wrong here. So you can actually point out that which rule is being presented wrong. So I would definitely love to hear it from you. Y is equal to log to the base x of e. So this is the function. We know that the base of the log can be e, but can be x as well. That is the variable base. So if the base is variable, means x, what happens? But there is a rule which allows us. Look, students, we have this question next. We have options A, B, C, D. And what are these options? Actually, derivative of this is required. 1 by x natural log of x whole square. Can this be answer? And the option B states that, can this be answer? 1 by x, can this be answer? Minus 1 by x natural log of x. So D states that 1 by e is answer. So if we try to figure out by applying rules, we will come to know that what is the correct option. So look, this is y is equal to log to the base x of e. If we consider it log by 1, then we can invert it in this form. Log rule allows that. When we invert it, base end on which the log applies, they get exchanged with each other. Means e becomes base and x will be the value on which log applies. And then 1 by log to the base e. log to the base e is denoted by a natural log. So natural log of x it becomes. Actually, the function, by applying simple rules of logarithm, becomes this natural log of x, which can further be written as natural log of x power minus 1, because in the denominator its power can be considered 1, and the numerator its power can be written as minus 1. Now we are going to differentiate it. So viewers, thank you for joining our channel. Differentiate with respect to x. So if we differentiate, we get dy by dx. Actually, we are applying d by dx on the both sides. Natural log of x power minus 1. So we know that power rule works here. We bring the power in the beginning and write the function with its power minus 1, and then differentiate the function without power. So let us look at it. Minus 1, this is natural log of x power minus 2, and you know that what is the derivative of natural log of x? It is 1 by x. So viewers, do you know that this can be written as x is already in the denominator, natural log of x squared can be written with it, because power minus 2 becomes plus 2 in the denominator. So this is the correct option. And where can we see it? Is it shown anywhere? Actually, the first option had minus sign here also. So it was already written. I'm not just transforming. This is correct option. So I hope you are enjoying this mathematical concepts being presented, and you can watch this all as well clearly. And this is what we are presenting, viewers. Please don't forget to hit the like button. Your support is like oxygen for us. I used to mention it is very much precious. You're the great viewer, great audience, which is appearing on this channel. Obviously, there are channels who are presenting the entertainment stuff, and you're just not attracted towards them, and you are coming here to enjoy the pleasure the mathematics gives you, and it's a great thing. I'll appreciate it because you appreciate maths content being presented here. So let us move to another part, another question. So what that is, I think that the question which I'm selecting, you're gonna like them also. So this is the question next I have. Y is equal to, it is series of square roots 10x plus not that it is actually log of x, natural log of x, natural log of x square root, plus is also in the middle, plus natural log of x plus natural log of x plus so on. This pattern continues to infinity. Now then the question is, what is dy by dx? The demand of this is, what is d by dx, means what is the derivative. So viewers, please hit the like button, share this channel, this live stream with your loved ones also, whosoever you think this is suitable for. Please share it with him. And A, B, C, D are the options. A, B, C, D are the options, and the options are look slightly strange. Natural log of x by 2y minus 1. So can this be answer? We will apply the differentiation rules to know what can be the answer, and we are just gonna do that. 2y minus 1 in product with x appearing in the denominator, and we have 1 by 2 y minus 1. So the guess doesn't work here, viewers. Guess doesn't work. The thing that works here is your math skills. Your math skill is higher, then you can crack it. Otherwise, can be hard. So let us look at it. Y is equal to make it slightly in the range, and to make it slightly easier form. This can be a challenging form, but can we make it slightly easier by squaring both sides? If we square both sides, we get y square, and we get the outermost root removed because of the square root. And see, the pattern continues. Natural log of x plus square root natural log of x plus 1 up to infinity can be called y square is equal to natural log of x. Now see that this pattern up to infinity is already named as y. This is already named as y, so we can write it y. Now we are going to differentiate it. We will be differentiating this one. I hope you can see it clearly. I have to use the other part of the board. Here it is. We are going to differentiate it, right? For that, we will be applying d by dx on it. D by dx of y square, d by dx of natural log of x, d by dx of y here. Then we can see that the derivative of y square is 2y dy by dx, okay? Equal to derivative of natural log of x is 1 by x dx by dx plus dy by dx stays like this. Then we can bring that value here on this side. So see that 2y dy by dx minus that value on this side will be subtracted, and we can see 1 by x dx by dx will be 1 here. So only dy by dx appears on left hand side, 1 by x appears on right side. So now we can take common. What can be taken common on left side? Clearly dy by dx can be taken common. Dy by dx is common, and if we write that commonly outside, what will be inside bracket that appears? 2y minus 1, and on right side it is 1 by x. So see guys, we needed dy by dx and we found it. If we shift this on the other side, right, it appears in the denominator. See that actually I had to draw an arrow which shows for it to appearance in the denominator. 1 by x 2y minus 1, this is answer. So can we see this answer anywhere in the options? 1 by x 2y minus 1 obviously is C option. So congratulations viewers finding this answer, supporting this channel, and staying live together, enjoying this math stuff here. You can only enjoy this all if you know what mathematics is. Otherwise, these things can be alien for you, can be so strange that even one symbol can be simply the symbol of the unknown language. So this is a mathematical language which actually gives you the pleasure when you solve this. So another masterpiece question we have solved, we have cracked, and you enjoyed. Please hit the like button, stay connected, because we are uh, presenting the math stuff with a great passion. Passion for mathematics is unprecedented, matchless here on this channel, and your support is like oxygen for us. So viewers, thank you so much for joining. Thank you so much for supporting, and let us have another great question for. So another great question is, You can write some comments also. One of the Shamir Zubair, hi, is writing hi. Hi, Shamir. Thank you so much for joining. If anybody else is also, uh, okay, Shanze is also saying hi. Hi, Shanze. I hope you are enjoying mathematics with this channel. Thank you. The other people can also send messages on the live chat, so I'll be answering those also. If you want me to solve any question, please send me that as well. I'll try my best to crack that also before you for you. And here we have another, so the two messages are also here from the audience. It's a great audience is actually watching this. Thank you so much, viewers. Hit the like button as well. Write and the comment whatever is in your mind. Okay, something about Taylor series. Do you know that Taylor series actually is to transform, is to find the center of the series, also to transform any function which obeys such some conditions, to transform that function into a series, right, around a particular center, suppose A. So a Taylor series can also be helpful in solving some of the problems when you are unable to actually find the limit or evaluate the limit of the function in its given form. You can transform it, if it is possible, into a series. So that series form is helpful in evaluation of the limit. So that can also be within mathematics, the Taylor series conversion or Taylor series expansion of a function is helpful. So here we have f of x. So is it visible? Yeah, it is visible. Yeah, yeah, it is visible. Now f of x is equal to f of a plus f prime of ax minus a and product, plus f double prime second order derivative at a by 2 factorial and x minus a square. Similarly, we can write a third order derivative at a by 3 factorial x minus a cube and so on. So this form continues till nth term is nth derivative evaluated at a by n factorial x minus a raised to power n plus 1. So this is infinite geometric series. It is stated that this for a function exists if, so if what? Number A, we have to choose the correct option. F is defined and the interval containing A interval containing A, an arbitrary number on which we are evaluating function and its derivative, can be seen in the series. B, the series is convergent. मुजतबा बेटे आप उधर चले जाएं, आप उधर चले जाएं. Thank you. The series is convergent at x is equal to A. C option, its derivatives of all order. Its derivative of all order exists at A. So it's something very, very technical information, purely mathematical. You can say that it is pure mathematics, right? Which gives you the definition, involves specific information about mathematical structure. So see that students, audience, thank you so much for joining. I can see Shamir Zubair's message. He says hi, and then Shanse said hi. Hi Shanse, hi Shamir. Thank you so much for joining and supporting this channel. Please hit the like button. So here is another challenge for you all to select the correct option. F is defined in the interval containing A is essential because everywhere function is evaluated on A. When function is evaluated on A, then it has to be defined on A. So first option is absolutely correct. Let us look at B. The series is okay. The word that is missing here is series. Okay. Series. The series is convergent at A. Obviously only convergent series are valuable, are useful for why they are useful, because they can be used, we are able to use them. Convergent series. Divergent series are not useful. So if we see at C option, so B is correct, absolutely correct. B, the series must be convergent, the function must be defined at A. The two options are correct. Look at the third option. Its derivative of all order exists at A. See the first line, we are evaluating function and its derivatives of all orders on A. See that what is written here, f prime of A. F of A means function is defined, f prime of A means derivative, first derivative is evaluated, f double prime of A means second derivative evaluated, third derivative, nth order derivative, well, all derivatives are evaluated at A, means we are evaluating derivatives on A and the function as well. So the C option is also absolutely correct. So for this particular question, the D answer is the best, because all these conditions are essential for Taylor series to exist. Function must be defined, series must be convergent, and its all derivative must exist at A. Means must, are we are able to find, are they exist, means their value can be found at A, derivatives. So all these three options are correct. So delta option actually is making that confirm that all these three are correct. So I hope viewers, you are enjoying learning with this channel. Thank you so much for joining. Please be part of this great math presentation where you are going to learn some key math concepts. Now in these couple of days I have 3 to 4 live streams. In all those I have discussed questions based on derivative concept. Okay, so the derivative concept is being presented, being discussed in all possible ways. Okay, so obviously here the derivative is involved because f prime, f double prime, f triple prime means their derivative function and its derivatives are evaluated at A, and in differentiation using derivative of the function, we convert a function into a series form. When the function, whether exponential, logarithmic, trigonometric, doesn't work in its original form, we transform that into series form using Maclaurin series, using Taylor series. So the conditions that the Taylor series conditions that Taylor series exists for a function are these all which we have presented now. And if we look at, okay, there is a question in which we are gonna looking how the series can be obtained, how a function can be converted into series form. So let us do that. Thank you so much, students, audience, for joining to this channel. Please hit the like button, write message in the comment section, the live chat. Please write a comment. One of the audience member said hi to me. Thank you. I'm also saying hi and in response. So thank you so much for joining. Thank you so much for showing love for mathematics. I'm here with a great passion for the subject. So I need your support. Your support is like oxygen for me. So please keep supporting this uh, great math presentation, which is based on derivative. So the derivative is actually being discussed in all possible ways. And these couple of live streams, yesterday, the day before, and these 2 to 3 days, I have some live streams on derivatives only, right? So we are just proceeding with the time and going to discuss some more topics also apart from the derivative. Next to it, we will have integration, the topic of integration. And the students, audience, you know that this presentation is actually entry test preparation. These are entry test preparation classes where we are discussing all these concepts according to entry test perspective. So if you are you have done with your FSC, done with your ICS, done with your A levels, you can join these classes to learn the way we use derivative, the way we solve a question based on derivative concept. So here we have to identify what is this series of, right? So what is this, the series of? This is 1 minus x square by 2 factorial. How can we identify a series that which function this series is of? So let us discuss that here. X power 4 by 4 factorial minus x power 6 by 6 factorial, and so on. So this is the series given, and we are asked is expansion of. Look, what is the question? This is an expansion of. So options, option A here, B, C, D. What are these options? Possible options are sin x. Is this sin x? The series of sin x, or cos x, or natural log of 1 plus x, or ex. What is this series of? So if you are the math genius, you must know it. How can we identify this? There are two ways. In one way, we can just find the value from this. These are two actually functions written in option A, B, C, D. These are functions. And the one is written in the series form, that is also a function. So when we have functions, we can compare the values of the two functions. Then we can come to know that which where the values of the two functions, which two functions value is matching, or which function the values of the series form, which function the values of the series form matching with from option A, B, C, D. So how can we do it? If we evaluate, if we put 0 in and the series, what do we get? value of x 0 will make all these terms having x, they will be 0. So answer at 0, if we call it a function, right? If we call it a function in the series form, if we put 0 in it, only 1 will left. So at 0 its value is 1, right? At 0 its value is 1, f of 0 will be 1. And if you put value 0 in cos function, that will also give 1. This is a clue. Sine 0 is 0, cos 0 is 1, so matching with that. Okay, and see, if we put 0 in it, 1 plus 0 will be 0, natural log of 1, natural log of 1 is 0, so it gives 0 value, it gives 0 value. And look, I'm just not underlining cos x only because its value at 0 matches with that function. And if we see D option, right? If we see the option D, what does option D give? E power 0, 1. So these two can be possible answers, right? So how can we identify the correct from these two? How can we find correct from these two? We can find correct from these two by putting another value. For example, if we put 90 in it, right? If we put 90 in it, e power 90 is whatever, we don't know. Now we just reduced our options. It can be B or it can be D. It can be beta or it can be delta. So which is correct? So if we put 90 in it, cos 90 is 0. If we put 90 here, so that is cos 90 is 0. That doesn't give us the value actually. So the other method, most probability, another thing is that another concept which we can use to identify is that this all is even function. The series, if we look at the series, it is an even function because if we replace x by minus x, all x powers are even, so that becomes positive. So this is an even function, right? Students, viewers, this is an even function, and cos is also even function. So my vote is for cos, right? And this is not an even function because if we substitute, it is neither even nor odd, or we can evaluate it. Look, if I put minus x in it, so e power minus x is 1 by ex, so that is neither even nor odd form, right? And if we put f of x minus x in it, that becomes cos minus x, and we know that cos minus x becomes cos x. So this is even function, this is even, and this is even. So two things are matching between cos and this series. So according to my finding, right, and that is 100% correct, I'm using two concepts. What are the two concepts I used here to identify? First thing, I evaluated this at 0, this gives 1 value, cos 0 gives 1. Coincidentally, e power x also at 0 gives 1 value, so they can be, any one of them can be the answer, B, D. But then we apply another concept. This series function is even and cos is also even, so but this is not even function, it means that B is correct option. Now we have another method. This is the method we are guessing it by, right? Now we are gonna apply another method to find whether this to check whether cos x, the finding is correct or not. So viewers, stay connected, stick around for more math stuff. So more math stuff will be presented. We are discussing this very question where we have to identify given series, what is it the series of. So the guess is cos x. Now how to verify, right? This is the way we are going to verify it by, right? How can we verify? Look at it. F of x is cos x. If we evaluate 8 at 0. Cos 0 is 1. That is the first value, right? F prime of x, its derivative is minus sign. At 0, sine 0 is 0. Third derivative, second derivative. Look at it, minus sign. Sine derivative is cos. And if we substitute 0 in it, cos 0 gives 1 and that becomes minus 1 because the minus sign is also appearing with the cos. Third derivative will also be 0 because cos derivative is minus sign and that becomes sine, and evaluation of it, evaluation of it at 0 is 0. Another thing, viewers, can be verified by is that see that the odd derivatives, look, odd derivative is 0. First derivative means odd, third derivative means odd. Odd derivatives are 0. These terms are not appearing here. Only even terms are, even powers are appearing, even terms are appearing, even factorials are appearing. So that is also clue that this is an even function, and cos is even function. This is not even function. So cos x is, now if we utilize this information and some more, because fourth order derivative can also be found. For example, if we find fourth order derivative, what is that? Fourth order derivative, it is third order derivative sine, fourth order derivative will be cos. So fourth order derivative of x, and that will be evaluated at 0, cos 0 will be 1. Fifth order derivative will be 0. Sixth order derivative will be, sixth order derivative at 0 will be what? Look at it. First is 1, 0 minus 1. Then 0 of sixth order can be calculated. Okay, fifth order derivative will be 0 because that will be sine. Third is sine, fourth is cos, right? Fourth is cos, fifth is sine, that becomes 0. Sixth will be sine derivative will be cos derivative minus sine, that will be minus cos. So it will be minus 1. Sixth derivative at 0 will be minus 1. Okay, so see that second derivative, what are you looking at? First term is alive, first term is 1, right? Third derivative is 0. Fourth derivative, look, fourth derivative is evaluated. Fourth derivative at 0 is 1. Fifth derivative is not there. Sixth derivative is minus 1. So this is minus. Fourth derivative is alive. Second derivative alive. First, the value of the function is 1. So all clues actually point towards cos x, that these two are matching, cos x along matching with this series. So this is the series of cos function, and we can apply the formula of the Maclaurin series also to find the series, find actually the series of cos, which will definitely be what is given here. So it means that we are successful in finding that series, identification of the function from the series by applying some of concept techniques. So here is another problem, that y is equal to x power x. So if we have y is equal to viewers, here is the new question. Let us discuss this concept. What this is going to be, y is equal to x power x, right? Have you seen it before? If y is equal to x power x, then what is dy by dx? Can you guess that? What is dy by dx? So see that, viewers, please, I would like to request you to hit the like button, subscribe button also, and please share this live stream with your friends, loved ones, whom you think this is going to be, for whom it will be beneficial, right? They related to them, beneficial for them. Please share it with them. So here is y is equal to x power x, then what dy by dx is possibly. So dy by dx possibly is this, and are you convinced with it that this is possible? Plus 1 is also appearing in the bracket. B option is x power x along with natural log of x. C option is x in product with another x with the power x minus 1. So none of these is also the fourth option, none of these. So what is your guess? Guess, actually in mathematics, guesses do not work. The thing that works is your mathematical concept, and application of that concept properly, accurately, leads you to correct solution. So I hope you can watch it clearly. So let us see that y is equal to x power x. How can this be cracked? Actually, that's the form on which no derivative rule can be applied. Actually, no mathematical, no derivative rule applies on this form, because this is some strange form. So when such form appears, we transform it and bring it into range of the derivative rule. So for that we apply natural log of x power x, and then natural log of y, x natural log of x, and then we differentiate it. Right now it is in the range of the rules of derivative and can be differentiated, right? So let us differentiate it. D by dx of left hand side, which is natural log of y, d by dx of right hand side, and right hand side is x natural log of x. So product rule works on right side, and logarithmic differentiation applies on left side. So derivative of natural log of y is 1 by y dy by dx. And here on right side, what which rule is going to be applied is product rule. X is written first, and we apply d by dx on natural log, and then natural log, and we apply d by dx on the first function, which is x. Let us look at it. 1 by y dy by dx is equal to x. Natural log of x derivative is 1 by x dx by dx, plus natural log of x dx by dx is 1. So look, how can we form this? How can we arrange these values? Dy by dx we keep on left side, right? And we send this y on that side, where it is going to appear and numerator and product with all these values appearing on right hand side. So whatever is appearing, this is 1, and dx by dx will also be 1. So 1 plus natural log of x is here. 1 plus natural log of x. So do you know that, students, viewers, what are we up to? What are we going to find? We are going to find dy by dx in case of y is equal to x power x, right? So dy by dx finally is y. What is y? Y is x power x. So in place of y, we will write x power x, and along with that in bracket 1 plus natural log of x appears. So this is correct option. Which one? Can you identify? X power x, 1 plus natural log of x, it is option A is correct. So this is also an advanced mathematical concept which can be understood only by the students, by those viewers who are grade 12, are studying at a higher level than grade 12 and higher, right? So they can understand these concepts. These are differentiation, and actually not straightforward, but the differentiation at entry level questions. These are being solved, have been presented to the audience. So I hope that you are here as an audience. Obviously you love mathematics as a subject, you know its concepts. So it's great thing when your knowledge of mathematics is you know that Aristotle, Socrates, these people have also given the importance to mathematics as subject. So Abir Yunus has also watched. So what does Abir says? Sir, try making a 10 minutes video. Okay, of MCQs, you're solving entry test MCQs. Perform perform because many students want to watch these. Okay, Abir, thank you so much for giving this suggestion. I would like to actually, some of the videos which are pre-recorded, live stream can go longer than 10 minutes because it's a live stream, and I have selected questions and can want to present those questions. Thank you so much for your suggestion, your recommendation. I would like to record 10-minute video for you to watch that and to learn these concepts. I'll definitely keep in mind the viewpoint you have presented here. Thank you so much for writing in the comment section. I would like to request the other people among audience to write down your suggestions also. These are derivative concepts actually. It's a vast concept. These are can be applied. These concepts can be applied and many ways. So there are some of the ways are discussed here where we are applying these derivative concepts. So here is another. Okay, we have another concept, another way we are looking at derivative. So what that is, let us look at it. Actually, natural log of x is the function and its nth derivative is demanded, right? So let's look that. Can we y is equal to natural log of x is the function. If this, then nth order derivative d and y by dxn. So what is this equal to? Math genius, what this is equal to? So who is the math genius and the audience? Are you? So tell me, what is its nth derivative? It's a challenge for you. So can you crack this derivative problem? Here are few possibilities. Minus 1 power n factorial by x power n plus 1. The other possibility, minus 1 power n by n factorial, no, by x power n minus 1. And the third possibility, minus 1 power n plus 1 by x power n plus 1. And what is the fourth possibility? None of these. So what do you say? Math genius, what do you say? What's the possible outcome? So let us begin cracking this one. I'm not gonna challenge you anymore, but you can do it. Take out your notebook and can you solve before me? I'll be glad to see that. Derivative of y with respect to x, applying d by dx on left side, d by dx on right side. Without application, if I directly evaluate that 1 by x, can be written as x power minus 1. If we differentiate it again, second order derivative will be, look, power will be in the beginning and we write power minus 1. That will make it minus 1 power x minus 2, right? Third order derivative. What is the third order derivative? Minus 1, then with it minus 2 appears, then x power minus 3. Fourth order derivative. Minus 1, minus 2, minus 3, x power minus 4. Can you see the pattern? What the pattern is appearing, fourth order. And if we generalize it, d and y by dxn. This generalization allows us to write the nth order derivative. And what that can be. Minus 1 appears in fourth derivative, See that minus 1 appearing 3 times. So minus 1 power can be write, minus 1 power can be written n times, minus 1 power n. And what else is appearing? Factorial is also appearing. See that in the fourth derivative, it is the third derivative, fourth derivative, third derivative has appeared. See that we can write a third derivative here, right? If it is fourth order derivative, the factorial appearing is a third derivative. So in nth, the derivative that will appear is n minus 1 factorial. And see that in fourth derivative, we can see it from not only from the one example, but we have to look. Second derivative power is minus 2, x power is minus 2. Third derivative x power is minus 3. Fourth derivative x power is minus 4. Nth derivative x power is minus n, that appears as n in the denominator. So this is the nth order when the function is natural log of x. Natural log of x is the function, and its nth order derivative is this one, which is nowhere actually appearing. So none of these is correct option, because we know the correct answer, which is not here. So none of these is correct option. Thank you so much, viewers, for being great audience of this math channel. Passion for mathematics is unprecedented. Please join us again. Also, I'll have live stream every day. I would like to do multiple live streams, not only one. Some of the audience have suggested some views, some great suggestions they came across, and I've noted that. Inshallah, I'll implement on those suggestions. I'll make that part of our channel, make those improvements which they have suggested. Thank you so much for joining, for supporting, for watching, for writing the comment, for hitting the like button, for subscribing the channel, for learning math concepts. So thank you so much. Actually, recently, students, one of the channel on YouTube, I have learned a concept which I would like to tell you also what that concept is. Whenever in object's speed, it is physics concept which I have learned, but let us share it with you. Whenever an object is moved at a bigger speed, as its speed increases, its mass also increases. And how much? You know that as the object speed gets closer to speed of light, the object's mass gets bigger, higher, more and more it gets increased. And as the speed of light speed gets closer, as object speed gets closer to speed of light, its mass gets closer to infinity. Its mass becomes infinite. So as the object get closer to the object around us, the object which have mass, right? There is an object, there is a particle which is thought to exist. That particle actually moves more than speed of light. That has a speed more than speed of light. If its speed is reduced to speed of light, its speed as its own speed is more than speed of light, when its speed is reduced to get closer to speed of light, its mass decreases, even vanishes. Its mass decreases to sorry, its mass also increases. So whether an object which is at rest, its speed increases and gets closer to speed of light, its mass also increases. And a particle whose speed is more than speed of light, if its speed is decreased to speed of light, its mass also increases to infinity. So that is a concept which I have learned from one of the YouTube channel. I wanted to share it with you. Some more great ideas I want to share with you. If you will be part of our channel, please join this channel again and be our permanent audience and support this channel, support these concepts, because the passion behind learning and presenting this all stuff is unprecedented and is great and is infinite. Thank you so much for joining. Let us end this today's live stream. Allah Hafiz.